Okay, so the next important point we are going to talk about today is the vector product of two vectors. This is something you haven't learned in year 11. The vector product of two vectors results in the vector answer. So, if you have two arrows, you cross them together, you give you another arrow. And you only use this for vectors in 3 dimensions. So you will not cross two vectors in 2 dimensions or 4 dimensions. You only cross them in 3 dimensions. I will explain why this is the case later, but now let's just focus on how you do it at first. If you define C as the result of A cross B, then the first component of C will be A2 B3 minus A3 B2. So this means you take the second component of A times by the third component of B, then you minus it by the third component of A times the second component of B. And this may seem very complicated, but there's actually a nice way to remember it. So how to remember it? You imagine this circle drawn here with an anti-clockwise going, and you label it as 1, 2, 3. So your first component, if you want to know what it is, C1, you just cover up this one here, and then you go with the circle. Next one is 2, so we have A2 here. This is the first one, the second component. And you go again, so you have 3, B3 here. And then you need to remember there's another term, and it has a minus sign in front. It's the only thing you need to remember. And you go the other way, you go clockwise. You go cross second 1. You have 3 here, so minus A3 and 2, B2. So it means whenever you go anti-clockwise, you'll be the positive direction. You have a positive sign here. And whenever you go clockwise, it will be negative here. So you get this result. And it works for the other 2 components as well. So you have C2 here, cover this up, and go with a circle, A3, B1, and go the other way, minus A1, B3. So how to remember this is when you take your right hand out, and then I have said N is perpendicular to both A and B. So in this case, if A and B lies in this screen, how do you find a vector that is perpendicular to both A and B? And the answer is you go in or out of the screen. So out of the screen will be pointing straight towards you, and in the screen will be pointing away from you. But you may be wondering, which vector do I need to use? Do I use the out of screen one or the in screen one? And the answer for that is you need to take out your right hand. So first, you point your index finger in the direction of A. So in the direction of A. Sorry here, I drew your index finger looks an arrow, but this is the best drawing I can do for your hand. Sorry, I'm not an arts teacher. And the second point, you point your middle finger in the direction of B here. And now your thumb will point towards the direction of A cross B. And so in this case, A cross B will be up. And from this, you can see why it doesn't make sense to talk about cross product in 2 dimensions. As you cannot find a third vector that is perpendicular to the only 2 existing dimensions. So here, you have a plane here, A and B lives in this plane. If you only talk about 2 dimensions, you cannot do the cross product because the cross product will be, or equivalently, you can also compute your cross product in the matrix way. So what you do is you write ijk, the unit vectors in the xyz direction in the first column, and the components of A, A1, A2, A3 in the second row, and B1, B2, B3 in the third row. And then you compute the determinant of this big 3x3 matrix. How to compute the determinant of 3x3 matrix? It's simple. You break them apart. First thing you see is this I here. So you take this I here, and then you just ignore this row and this column, and you will be left with this sub matrix. So this A2, A3, B2, B3. And you compute the determinant of this 2x2 matrix. And 2x2 matrix, I hope you will remember how to compute the determinant from 11. If you don't remember, that's okay. You can use this thing to memorize it. This thing. So what you do is you take the positive of this diagonal, and then you take the negative of this 2 diagonal. So what you do is a2 b3 minus a3 b2. And the same works for the other two as well. So for example, the kth component, you look at k here, you cross this out, and then you'll be left with these two, and you just compute the determinant here. But one thing you need to be aware is about the negative sign in the middle. For the j component, there will be a negative in the middle, and you will be aware of that. But if you calculate all this out, you will get the same formula as this. And now there's also some important properties you need to remember for cross product. First one, important, a cross a equals 0. So if you have any vector, you cross it with itself, you will get a 0 vector out. This is because the cross product actually tells you how two vectors are perpendicular. And obviously a vector is parallel to itself. So its cross product with itself will get you 0, as you have 0 perpendicular components. And the second one is very strange. A cross b equals negative b cross a. This means cross product is non-commutative. If you swap the order of your cross product, you have an opposite sign in front. This will mean it's in the other direction. You need to remember this not the same as what you normally get. And the third one is the distributive. It's similar to dot product. This one now, you just expand the bracket, nothing too fancy here. But the next one is called the scalar triple product. You cross two vectors and then you dot it with another one, and this will result in a number, because this is a vector and the vector dot with another vector will give a number. And then what this formula tells you is that you can basically swap the order of the cross and dot. It doesn't matter, but it matters though in the vector triple product. So in the cross product is sometimes very strange. You cannot swap things easily here. So it tells you if you have b cross c and then cross it with a, this will be equal to b times c dot a minus c times b dot a. How to remember that? Is by the cyclic weight. Similarly, you write a circle here and then you label it in the anti-cross direction. That's the positive one. And then you look which vector is being crossed first. So you see it's b cross c first, and then b for the first one. So you recover b here, and then go with a circle c dot a. So we have b times c dot a. And then the second one, c, but it has a negative sign here. Second one usually has a negative sign here. And so you have c, negative sign, go. And similar to the dot product, we are going to talk about the geometrical interpretation of cross product here also. So a cross b equals modulus of a times the modulus of b times the sine of theta times n. And this n is a unit vector perpendicular to both a and b. And since n is a unit vector, it has a magnitude of 1. And theta, we define it to be between 0 and 180. So it's this angle, is between 0 and 180. We are not using this large angle here. We're using the small one here. And so the sine of theta in this domain will be positive. As you know, sine between 1 and 80 is in the first and second quadrant of the unit circle, is up, is wide components, is positive. So the magnitude of the cross product is then this thing. This is positive, you omit this one, and you get this one. And you curl it in the anti-clockwise direction, you get the thumbs up, and it's a positive thing. And why anti-clockwise is positive, I don't know, because mathematicians just define it in this way, pointing in or out of plane, but you don't have an in or out of plane direction, you only have this plane. And the last point, we're going to talk about the geometrical interpretation of the modulus of a and a cross b. The area of a parallelogram in space defined by a and b will be equal to the modulus of a and b. So what does this mean? Is if you have a here and b here, they make the side of a parallelogram, and you want to find the area of this parallelogram, it will be the magnitude of a cross b. Now let's do an example of how you use cross product. Find two vectors with length 3 units which are perpendicular to both A and B here. So after reading this question, you see the word perpendicular. If you see perpendicular between two vectors, this means you need to use the dot product. But for this case, you need to find another perpendicular vector. So you need to use the cross product in this case. So you compute the cross product between A and B. For this question, it does not matter if you use A cross B or B cross A. In the end, you get the same result. And you use the determinant method, ijk here, and put your component of A here, -1, 0, 3. A doesn't have a j component, so it will be a 0 here. And put your B here. And you compute the determinant. You first have an I here, cross this out, you're left with this submatrix, 0, 3, -1, 1. And then you do the same thing for the other two, but where there's a negative sign in front of the j here. And then you compute the determinant. It will be plus 0 times 1 minus 3 times -1. So 0 minus -3. This will give you 3i. And for the other two components, you will get plus 7j plus k. This is a vector that is perpendicular to both A and B, but it's not the only vector, as you can just multiply this thing by 2, make it twice as long, and they will still be perpendicular to it. So all the vectors that are perpendicular to A and B will therefore take the form V equals to lambda times the cross product you get, where lambda is a scalar. It basically scales your vector up or down, longer or shorter. And now, according to the question, we need to find two vectors with length of 3. And obviously, they will be in opposite direction, as one will be length of 3 pointing up, and one will length of 3 pointing down. We'll do in the next page. So this is the result V from the previous slide. We need the length of V to be 3. So we take the length of this. For the scalar lambda, we just take its absolute value. And for the vector here, we take its magnitude. It's the first component squared, clockwise, B dot A. C times B dot A, you get this formula here. Squared plus the third component squared. The third component is just 1, so we have 1 squared, 1k here. You add them up all together, and then you take the square root, and you compute this, and you get square root of 59. That's the length of this vector here, and you divide this over, you find the absolute value of lambda is 3 over square root of 59. And then what you do is you take out the absolute value sign, but you need a plus or minus sign here. You get lambda is this thing. This is your two lambdas. So the first one, the positive one, in the upward direction, V is equal to 3 over the square root of 59 and times the cross product you get. And the other one, in the opposite direction, will be minus 3 over square root of 51 times the original cross product you get. So this will be your two answers. And now that's all for today. Thank you guys. And next time we will talk about vector applications.